Today, I shall be taking you through differential equations. Differential equations are forms of equations extensively used in engineering, from aerospace engineering to mechanical engineering, from electrical engineering to civil engineering. They all use differential equations. Talking about the general form of the differential equation, yes, we realize that we have the homogeneous differential equation, we have the non-homogeneous differential equation. Talking also about the types of the differential equations, we also have the ordinary differential equations, we have the partial differential equations. But when you talk of differential equations, what do we mean? That is exactly what today I shall be taking you through. Yes, differential equations. Differential equations. Differential equations has a very simple definition. When we talk of a differential equation, we are simply referring to an equation that involves a derivative. What do I mean by that? Well, let me take you through some basics. Now, we all see this equation. We are used to this equation. This is just the equation of a line. But let's see if we can have another way of writing this same equation. Well, now we have our y-axis, we have our x-axis, and then we just want to find the gradient of this very line. Okay, so we have our initial x, so you see x naught. We also have our x here, and then we have our initial y, and now I will call it y naught. Okay, and then we have our final y. Okay, and then yes, we have our initial point that happens to be the 0. Okay, now how do you find the gradient of this line? From the equation of the line, we know y is equal to ms plus c, and then the m happens to be the gradient. Yes, so we say that here you can have x minus x naught, and that you're going to call it the change in x. And then here also we have y minus y naught, and then we are going to call it change in what? Y. Okay, fine. So here it tells us that we have our gradient, that is the m. Our m happens to be what? M happens to be the change in x. So we have x minus x naught. Yes, the x happens to be the final x, and then the x naught happens to be the initial of the x. Okay. So knowing that, we know the general formula is the change in y out of the change in x. So we have y minus y naught. So we know the y here happens to be the final y, and then our y naught happens to be the initial y out of our x minus x naught. Yes, good. Now with the change here, we have another way of writing this change, and that happens to be m is equal to change in y out of change in x. Now we can apply our limit to this, and applying the limit, we say our gradient m happens to be the limit of change in what? Y out of change in x, as change in x approaches what? 0. Yes. So finding the limit of change in y by change in x, we say our gradient happens to be what? The y dx. Fantastic. Yes, so now we have got a different way of writing the same gradient. So what do we do? Y is equal to ms plus c. We can simply write that to be m, or y is equal to, we have our m, that is the y out of the x, and then we have our x here plus c. Please take note of the different way by which we have been able to do what? Write our equation of a line. Let me give you another example. Now we know Newton's first equation of motion, that is V is equal to U plus AT. Yeah, V is equal to U plus AT. But I'm going to change it this time to write that we have V is equal to AT plus U. Okay, and I'm going to represent this on the diagram. So we can have this. So we can say that we have our V, we have our T, and then the initial. So we have a line this way. Okay, so now it tells us that finding the gradient, we have our initial T, so that I'm going to call it T naught, and then we have our final T, and then we have our initial V, that is U, and then we have our final V. So it means that the U is the initial velocity, and then the V happens to be the final velocity. Okay, as we did to the line, we're going to do the same also to this. So we have T minus T naught, and then change in T, and then we have V minus U, and then change in V. Okay, fine. Now, what is the gradient of this line that we have drawn? Yes, the V here represents the velocity and the T here represents the time. For that matter, we can confidently say that our gradient happens to be the acceleration, which is what? A. Okay, so this is the gradient, and the gradient happens to be our A, which is acceleration. Okay, so we can simply write our acceleration here, A, to be change in V out of change in T. So V minus U out of T minus T naught. So we say A is equal to the change in the velocity out of the change in what? Time. Yes. So taking the limit, we say our A happens to be the limit of the change in V out of the change in T as change in T approaches what? 0. And once change in T approaches 0, it tells us that our acceleration A happens to be the V out of the T. Yes, now that we have our acceleration in this form, the V out of the T, we can rewrite the whole of the first equation of motion. That happens to be V is equal to our A, that is the V out of the T, and then we have our T, and then plus U. Yes, this is the different way by which we can write our Newton's first equation of motion. So now let's take note of this. We have this to be the equation of a line. The y represents the y-axis, the x represents the x-axis. We know the m to be the gradient, and then we know the c also to be the y-intercept. Okay, fine. Now we have written it in a different form. This, the y, the x, is what we call the derivative. Yes, the y, the x is what we call derivative. Now when you come to this equation also, we have V is equal to U plus AT, where V happens to be the final velocity, A happens to be the acceleration, T happens to be the time, and then U happens to be the initial velocity, and we have transformed it, that is, we have written it in a different form. This time we have V is equal to the V dt times the time and then plus U. This, the V dt, is the derivative we are talking about here. Yes, so when we talk of a derivative, we are simply referring to a gradient. A derivative simply refers to a gradient. So, as at this time, I think we can say that a derivative is the same as gradient and is the same as differential. So, when you talk of a differential equation, we are simply referring to an equation that involves a derivative like we have here, or a gradient, of course, as we have here, or a differential as we have here. This is all what we refer to as what? A differential equation. So look at the two equations. We have dy dx, which is differential. We have dv dt, which is also differential. Yes. So what is the differential equation up to this very point? When you talk of a differential equation, we are simply referring to an equation that involves a differential or a gradient or a derivative. That is a simple definition of a differential equation. In my next presentation, I'm going to take you through the general form of a differential equation. Watch out!